The first thing you want to do is measure yourself out 0.2 grams approximately of magnesium ribbon. Take your magnesium ribbon and use the steel wool to knock off the outside magnesium oxide layer, known as a passivation layer, and get yourself some nice bright shiny magnesium. Cut that magnesium ribbon down into very small squares. Try to keep them smaller than 3 millimeters with a pair of scissors and put them into the round bottom flask. Here we can see the reaction apparatus that we are going to perform our Grignard reaction in. We are going to use a couple of the adapters to attach a drying tube to a Claisen adapter, under which we will fit a round bottom flask, 25 milliliter to be specific. In the drying tube, we are going to pack a little bit of cotton down into the bottom and add some calcium sulfate drying granules to prevent any water from coming into our reaction. Here I have the entire apparatus set up and clamped over a magnetic stir bar plate. The magnetic stir bar has been added to the flask with my magnesium strips cut up, and the Claisen adapter has been topped with a cap and a silicone rubber septum on top. So into that silicone rubber septum we can puncture our needle and deliver our reaction mixture again while inhibiting any moisture from coming into our reaction mixture. So I'm going to load my needle and syringe with the ether and bromobenzene mixture. After which I'm going to slowly and carefully start to deliver it to the 25 milliliter round bottom flask. I try to get it to run down the sides a little bit with so I'm not splashing it everywhere, injecting it straight towards the bottom of the flask. So gently this first time I delivered about 3 milliliters to the reaction flask and waited to see if I see any action. And we're going to look for a little bit of cloudiness or color change to a brown or bubbling on our magnesium to see if the reaction begins. And generally this is going to take anywhere from 5 to 10 minutes before we really start to see the reaction start to go. I added a little bit more of the ether and bromobenzene mixture to my reaction flask. I then clicked on the stirring and waited for any indication of some reaction starting to begin. After sitting around for a little while and watching the magnesium and ether mixture spin, I did not see any indication of reaction happening even after warming a little bit with my hand and things like that. So I eventually introduced a piece of iodine into the reaction mixture, and that helped to push the reaction on pretty quickly, in fact. After the iodine was mixed in, I started to see the iodine color go away and the reaction mixture started to turn cloudy. And I added a little bit more of the ether and bromobenzene mixture, and I started to notice some bubbling around this time. So I wait around for a little bit longer and I speed this part up a little bit, and I do notice some bubbling action in my reaction. So I add a little bit more of the bromobenzene ether mixture, and then I really start to see some bubbling start to take place, and the reaction should soon start to take place in earnest and almost keep itself in a state of reflux without any addition of heat, just of the heat released from the reaction. So I waited around a little bit longer, and I finally started to see the color of the iodine disappearing and the reaction mixture becoming more and more cloudy. Finally, as all of the color of the iodine left the reaction vessel and the solution turned a really kind of milky, cloudy looking color, I started to really see some bubbling around the magnesium chips, and I knew that I had started to really form the Grignard reagent. Here we can see the reaction has now really reached a state of sustaining itself with the heat it's creating or releasing as the reaction takes place. It's kind of reached this state of reflux. It's kind of hard to see, but if you look close when you are in the lab, you will see the solvent evaporating and then cooling and condensing and coming back down the walls to mimic a sort of a reflux setup for this reaction. We're going to allow this to keep going until all of the bubbling has stopped. So once the reaction is complete, it will start to cool back down, and we're going to allow it to cool to room temperature once it has stopped. And we should expect to see a brown liquid that's clarified a little bit. It will still be a little bit cloudy, but perhaps not as cloudy as before when we are done, and maybe some magnesium still left in the bottom. But once all of the bubbling has stopped, we know that the majority of the reaction has completed, and we're waiting for the cool down. Here is some close-ups of the reaction action, and some more from the bottom. Things are somewhat starting to wind down now as we're looking at the magnesium still reacting with the bromobenzene mixture, forming the Grignard reagent, but we should start to see it wind down and the bubbling start to cool down after a while, and then we're going to allow this to naturally cool off to room temperature. So now we can see our fully formed Grignard reagent, and we've let it cool to room temperature, and now it is not time to add the other reactant, the benzophenone, dissolved in some ether as well. And you can see, or you will see, as we introduce the reactant to the Grignard reagent, we really see a quick reaction take place. There's an immediate color change to a dark purple red, followed by maybe a lighter pink, and we will start to see some bubbling resume as this reaction takes place. It is also exothermic, and so it is going to start to reflux itself, as we saw with the formation of the Grignard reagent. And we are going to slowly and gently add our reagent to avoid refluxing over and out of the reaction vessel. We're going to go a little somewhat slow to keep that temperature within a reasonable means. And after we add most of our reagent or all of our reagent, we are going to allow this reaction to go until it quits bubbling and quits reacting and cools off to room temperature, as we did with the Grignard reagent. So as you continue to add your benzophenone ether mixture to the reaction flask to the Grignard reagent, you should see some more bubbling and refluxing of the reaction mixture. You probably will also start to see the formation of a white precipitate. This is the alkoxide intermediate in the reaction that we are going to protonate in the second step of the reaction to form our triphenylmethanol. And so this would be triphenyl methoxide as the alkoxide intermediate. As the reaction proceeds and after you get all of your reactants mixed together, that will eventually form white clumps in the pink reaction mixture, and we're going to wait until everything's cool, and eventually the flask will be a really kind of chunky mixture of precipitate and leftover ether solvent. And here we see, after the reaction is completed, we have a flask full of the alkoxide intermediate that we are going to work up to our triphenylmethanol product with the following process.